Hello there. This is a video for you Mesa Boogie F-50 112 combo amp owners. Probably be good for the F-30, F-100 as well. Problem was reverb. I had no reverb signal at all in either the clean channel or the number 2 channel. With the foot switch or otherwise, there was just no signal at all. So looked for a video on YouTube somewhere and couldn't find one. So some forums provided some information that got me going in the right direction. I was able to obtain a schematic for the F-30, which is about the same. Matter of fact, the preamp and the reverb and the effects loop and such, which I'll go over, are the same. There are some differences in the power section and the power amp section, obviously. And anyway, got me going in the right direction, and I did find the problem and was able to fix it. So we'll go over that here in just a minute. And just as a disclaimer, I am not an amp tech. A lot of good videos online that talk about safety on these things. There's this thing here measured over here 463 volts on this end, so you really don't want to play with that without having a little knowledge of what's going on in here. And these preamp tubes are looking at 250 volts over here, so watch the videos, be very careful. Do not stick your probe or your hands or anything in here without having an idea where you're going with it. They're not telling lies, they're telling the truth about the power. Couple of tools that I made for this. I made this thing here, which is a discharge tool, just a probe on the end of a wood stick. And I got most of this off the net, but this is a 1K 10 watt resistor that I had laying around. And the only difference with the size of the resistor is going to be the time it takes to discharge. The capacitor, this takes about 12 seconds for 400 volts. The smaller capacitor will spark more when you touch it. This doesn't spark at all, it discharges it just fine. So you just clip one end to ground, and the other end you put on your caps and pull it down. And then you use your voltometer to make dang sure that that's all got no juice in it before you go putting your hands and your probe in there or soldering iron or whatever. Don't do that. Don't do that. Another tool I made, this was off the Magic cable, off the internet. Guy pretty much went over all the different values, but it's got a couple of resistors in here that I can feed into the input of the amp off my iPhone to have a signal trace. And that works okay. I mean, it's not real clear, but it's better than the one I made for the other solid state amp that I worked on. And I'm running it through a boom box up here, running it through the aux in, just so I could listen for where the signal goes. Works pretty good. The other tool that I made based on some internet stuff that I found was this is how I connect the signal probe up to the boom box right there, and then inside of that it's got some coupling capacitors and resistors. There's some good information on the internet about this, and the reason why it's in copper, I think, was for shielding, so I just kind of copied the idea. It's got a ground lug on it, and then the probe right here, so I can go probing around. So I made those three tools. Well, on the Mesa site, they've got a thing here to test your Accutronic tank right on the Mesa website. Works good, lasts a long time. My tank was okay, so went through that. I got this off of music electronics something.com or whatever. It was like a forum. Somebody posted this up. I think you might be able to call Mesa and get a schematic. I don't know. I figured this was close enough, being as I went and figured out where everything was. Kind of learned the system while I did it. The power supply section, obviously, this up here is somewhat different. the components, but and the voltages are all different. Gives you kind of an outlay though what's going on. This down here, the 15-volt supplies is the same. This was the same deal, and I believe this was too, the 3 and the 3 volt supplies down here for the heaters. That was the same too, so no problem there. The preamp section was identical between the F-30 and the F-50. Went through all this. Different stages of the 12AX7s and what have you. Take note that these J175s, we're going to talk about those. There's 6 of them on this board. And that comes out of there and goes into the reverb circuit. Comes in over here to V3. And then up through the reverb circuit, back out, down through these pots that control the feed out to the master volumes. Once again, take note, they got these J175s on this board. It looks like there's 6 of them, 7 of them on this board with the other 2. No, there's 6 of them total. Anyway, it was the same circuit. That's the. I'll show you this where this stuff is on the board in a minute. This is switching circuitry. This was the same. The contour circuit is a little different in the way the filters are, but relatively wired the same. Output section, J175 right there, was the same up right to here into the mute, and then the record out was the same, but this obviously with the EL84s was different on that. And then down here, this is the pulse generator for the switching thing that is designed to keep it from popping when you switch channels and what have you. This works out to be the same circuitry as well, as long as the foot switch. So and this over here is the reverb op amp, the input and output, both going both directions, and this is for the record out op amp right here, and the choke associated with that. Power tubes are up here, the screen resistors right there, and then we've got the foot switch plug-in over here, and the effects in and out ribbon cabled on over. Now here's looking at the schematic on the Reverb page. Oops, sorry about that. Basically the signal's coming off of pin 1 of V3. Coupled cap. I trace the signal all the way through this. Go through a 470 to 750 pico, up and over into this load resistor and into the pin 6 of the 5532, which was right there. And it comes out pin 7 good, loud, and strong, and then drops into the tank. Comes out of the tank and goes through this 002, which is right there, the coupling cap right there, and the number 2 on the same op amp, used twice. Comes into number 2, does its thing, comes through, comes out pin 1 through an 05 and a 470. Pin 1's up here in the front corner. This is the 05 right here, and this is the 470 resistor right here. And you can also trace your signal in through here too. It comes out through these little pin pads here, so you can actually sense it there. And that's where we got to the meat of this deal. Is right here. It came out. We had signal just kind of died right here. It just didn't do anything beyond this point. So we've got these J175s, which I read are notorious for failing. Okay, so essentially what I had was on the gate on this one right here. This is fed by 15 volts through a 3.3 meg resistor. I had what, 205 volts on that. It had nothing. Okay, so I think it was set to ground. I think to short it to ground right here. And this little thing, dude, is right down here. And what I did was I just cut the other one off and soldered it on top just to try it to see if it would work, and it did. That fixed it. So I'm just assuming that the whole thing was shorted to ground because internally they do that, and so the just went chook 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 boom all the way through. The way those things work is they apply a voltage from the gate, and then it blocks the voltage to the gate here, and it blocks the signal flow through here. Take the voltage off, and it allows the signal flow to go through there. Same thing with the foot switch up here. It has the same process. It's got a ground right here. They apply 15 volts through this resistor to there, and it blocks it. And then when they take the power off of it, it allows it to go to ground. That resistor for the foot switch, or correction transistor J175, is this dude right here. That's the foot switch. And then it's got a secondary, another ground circuit that it runs in the foot switch, which accomplished the same thing. So you see the voltages I had here were good the whole time. Anyway, that's what cued me off to this. Was it? I was expecting to see a J175 causing this problem, from what I'd read. So I just lifted the leg on the ground side, and it came to life. And so I just got another resistor. It was transistor was 46 cents, and that has solved the problem. So anyway, in order to get to that and replace it through the hole, you're going to have to remove all the knobs and all the stuff up here. So it's quite the job to go get that piece, the rest of it out, and solder it in there. But that's what happens to the reverb. It happened to this reverb, is that J175 is shorted to ground, and it was taking the voltage down with it, and everything. So there's a lot of these J175s in this system. We got the foot switch one, and then we've got other ones down here that are all controlled. These things, the purpose of these things is they have this mute circuit, and they're keep it from popping. That's just the whole purpose of that mute circuit. I got another one right here on this mute right there. But anyway, this circuit here these 4 chokes, along with these Darlington Trans 6426s, provide a pulse that takes the voltage off the J175, which allows it to conduct to ground. Isn't this a J175? But that's basically what it's doing. It doesn't go down by very much when you cycle it. It drops off a little bit, but I guess that's just enough to knock the signal down so it doesn't pop. So, man, for a non-electrical guy. Anyway, so there's the 3.3 meg that feeds the J175RM, which is the one I showed you, which is reverb mute. So anyway, that's the dealio, folks. For the reverb, it won't work. And if you have a switching problem or anything else, the channel doesn't work, from what I understand, it's most likely the J175, and there's a couple of them over here, there's a couple of them down here, the 1, 2 I showed you. But they're likely to be the ones that failed. And measuring them across the source and the drain, the only thing I noticed on it, when it was still on the board, was that it was about half the resistance that from a new one. And so it was, I think, like 76 ohms on a new one, and like 25 or 30 on the one that was in there. But I don't think that's the way you test it. So it just was shortened to ground, and that was the end of the story. So anyway, good luck.